Using the law of sines, we need to show that in the triangle ABC, the following trigonometric equation holds true. Let us begin. So what we'll do, let's first specify the law of sines. Here we have a triangle ABC, it's an acute angle triangle. Then the letters A, B and C, which are represented in lowercase, will be the sides of angle A, B and C respectively. Now, the law of sines states that the ratio of side A to that of the sine of the angle opposite to it, that's angle A, this ratio will be equals to the ratio of side B to that of sine of the angle opposite to it, so that's angle B, and it's also equals to the ratio of side C to that of the sine of the angle opposite to it, so that's it. So this is the law of sines. Now what we'll do, we are going to suppose that these three ratios are equal to a common constant, and we are going to call it 1 over lambda, such that sine A will be represented by A times lambda. Sine B will be represented by B times lambda, and sine C will be represented by C times lambda. So let's begin from the left hand side. On the left hand side, we are given 1 minus tangent of A over 2 times tangent of B over 2. And divided by 1 plus tangent of A over 2 times tangent of B over 2. So what we'll do, we're going to multiply both numerator and the denominator with cosine of A over 2 times cosine of B over 2. So let's do that. We have so this is going to give us cosine of A over 2 times cosine of B over 2 minus sine A over 2 times sine B over 2 whole divided by, so we have cosine of A over 2 times cosine of B over 2 plus sine A over 2 times sine B over 2. Now the numerator and the denominator are both standard values, so cosine of A over 2 times cosine of B over 2 minus cosine sine of A over 2 times sine of B over 2. So that is the expansion of cosine of A over 2 plus B over 2. And the denominator is the expansion of cosine of A over 2 minus B over 2. Now what we'll do, we'll multiply both numerator and the denominator with the factor 2. And we're also going to multiply both numerator and the denominator with sine A over 2 plus B over 2 and divided by sine A over 2 plus B over 2. Now we are doing this. So this was done so that the numerator portion can be reduced by using the formula that 2 times cosine theta multiplied to sine theta. So that is equivalent to sine 2 theta, which means we can represent the numerator as sine 2 times A plus B over 2 whole divided by, so in the denominator we have 2 times cosine of A over 2 minus B over 2 times sine of A over 2 plus B over 2. So here we are going to use the fact that 2 times sine A plus B over 2 multiplied to cosine of A minus B over 2. So that's equals to sine of A plus sine B. So that means our denominator will become sine A plus sine B. Right. So we can also factor out this 2, and this is going to leave us with sine A plus B in the numerator. We have sine of A plus B in the numerator, and in the denominator we have sine A plus sine B. That in a triangle ABC, the sum of the interior angles A plus B plus C, so that's pi radians. The A plus B can be also expressed as pi minus C. Now if we take the sign on both sides, so we have sine of A plus B, that will be equals to sine of pi minus C. So what's sine pi minus C? That's simply sine C. So we can say that sine of A plus B is equivalent to sine C. So our numerator now becomes sine C, and in the denominator we have sine A plus sine B. And we have already defined the value of sine A, sine B and sine C. So we have sine A lambda, sine B is B lambda, and sine C is C lambda. That means our expression will now become C lambda divided by A lambda plus B lambda. So factoring out lambda from the numerator and the denominator, we are left with C over A plus B. So this is the expression on the right hand side. Hence, by using the law of sines, we have successfully showed that in triangle ABC, the given trigonometric equation holds true.